Good day everyone, welcome, and today we will be discussing change of subject of the formula. Now we'll be discussing this based on the JAMB syllabus. Change of subject of the formula. The term change of subject of the formula implies transformation of a given formula to make another quantity, usually a letter, the subject of the formula. In doing it, basic mathematical rules must not be avoided. I will be explaining this using few examples. Now, our very first example is from 1989 and it states that make arrow the subject of the formula. S is equals to the square root of 2 arrow plus t divided by 2 arrow t, and we're given the option. Now for our solution, since arrow is under a square root, we take the square of both sides, and when we do that, it becomes s square is equals to 2 arrow plus t divided by 2 arrow t. Our next step is to cross multiply, and when we cross multiply, we get s square times 2 arrow t is equals to 2 arrow plus t. Now we simplify further by multiplying the left hand side. It becomes 2 arrow s squared t is equals to 2 arrow plus t, and our next step is to collect terms containing arrow together. When we do that, it becomes 2 arrow s squared t minus 2 arrow is equals to t. Now we're going to factor arrow out in our left hand side. When we factor arrow out, it becomes arrow into 2s squared t minus 2 in bracket is equals to t. Now to make arrow stand alone or make arrow our square formula, we're going to be dividing both sides by the coefficient of arrow, that's 2s squared t minus 2. And when we divide both sides by the coefficient of arrow, we get arrow to be equals to t divided by 2s squared t minus 2. We can always simplify further by factorizing our denominator, which should make arrow to be equals to t divided by 2 into s squared t minus 1. And our correct option is B. We have another question from 1990 and it states that express arrow in terms of p and q in the following equation. P divided by the square root of 2 equals to the square root of arrow divided by arrow plus q. Now for our solution, since arrow is under square root, we take the square of both sides, and doing so it becomes p divided by 2 to the power of half in bracket square will be equals to arrow divided by arrow plus q. Now squaring the left hand side becomes p square divided by 2 is equals to arrow divided by arrow plus q. Our next step is to cross multiply to remove fraction, so it becomes p square into arrow plus q is equals to 2 arrow. Next, we are going to be expanding our bracket on our left hand side, which will make our left hand side to become p square arrow plus p square q, which will be equals to 2 arrow. Now we are going to collect like terms, that collecting the terms containing arrow to one side, so it becomes p square q is equals to 2 arrow minus p square arrow. Now we're going to be factoring that arrow in our right hand side, and when we do that, it becomes p square q is equals to arrow into 2 minus p square. Now at this point, we're going to be dividing both sides by the coefficient of arrow, which is 2 minus p square, and when we divide both sides, it becomes p square q divided by 2 minus p square is equals to arrow, which will make arrow to be equals to p square q divided by 2 minus p square, and our correct option is A. We have another question and it's from 1993 and it states that make s the subject of the relation 1 plus as divided by 1 minus as is equal to p divided by q, and we're given the option. Now our very first step is to cross multiply to remove fraction, and when we do that, it becomes q into 1 plus as is equals to p into 1 minus as. Next, we are going to be expanding our brackets, and when we do that, it becomes q plus qas is equals to p minus pas. Our next step is to collect like terms or collect terms containing s together, which should make it to be qas plus pas is equals to p minus q. Now factoring s out in our left hand side, it becomes s into aq plus ap is equals to p minus q. Our next step is to divide both sides by the coefficient of s, which is aq plus ap, and when we do that, it becomes s is equals to p minus q divided by aq plus ap. Factorizing our denominator, as will be equals to p minus q divided by a into p plus q, and our correct option is B. We have another example from 1997, and it states that make f the subject of the formula t is equal to the square root of v divided by in bracket 1 over f plus 1 over g. Now for our solution, since f is under square root, we take the square of both sides, and when we do so, it becomes t square is equal to v divided by 1 over f plus 1 over g. Now to remove our brackets, we are going to be cross multiplying, and when we cross multiply, it becomes t square into 1 over f plus 1 over g is equals to v. Now we're going to simplify the bracket in our left hand side, and when we simplify the bracket, it becomes t square into g plus f divided by fg is equals to v, and expanding our bracket, it becomes t square into g plus f divided by fg is equals to v. Now our next step is to cross multiply, and when we cross multiply, we have t square into g plus f is equals to v fg. Now since f is in the bracket, we are going to be opening the bracket up, and when we open the bracket up, it becomes t square g plus t square f is equals to v f g. Collect terms containing f together, it becomes t square g is equals to v f g minus t square f. Now we are going to factor f out in our right hand side, and when we factor out f, it becomes gt square is equals to f into gv minus t square. Now we are going to divide both sides by the coefficient of f, that's gv minus t square, and when we divide both sides, it becomes gt square divided by gv minus t square is equals to f. We have another question from 1992, and this is going to be our final question. It states that make t the subject of the formula s is equal to ut plus half at square, and we're given the option. Now s is equal to ut plus half at square. Our first step is to multiply through by 2 to remove our fraction, and when we multiply through by 2, we get 2s is equals to 2ut plus at square. Rearranging, it becomes at square plus 2ut minus 2s is equals to 0. We can treat this as a quadratic equation with t as our unknown. Now comparing the above with as square plus bs plus c equals to 0, a is equals to a, b is equals to 2u, and c is equals to minus 2s. Now substituting into the general formula for quadratic equation, s is equals to minus b plus or minus the square root of b square minus 4ac all over 2a. t will be equals to minus 2u plus or minus the square root of 2u in bracket square minus 4 times a times in bracket minus 2s divided by 2a. Now simplifying our square roots, we get t is equals to minus 2u plus or minus the square root of 4u square plus 8as divided by 2a. Breaking it further, it becomes t is equals to minus 2u plus or minus the square root of 4 into u square plus 2a, that's factorizing our square root, divided by 2a. And when we simplify further by bringing out the square root of 4, which is 2r, we get t is equals to minus 2u plus 2 the square root of u square plus 2s in bracket divided by 2a. Now factorizing our numerator, we get t is equals to 2 in bracket minus 2 plus or minus the square root of u square plus 2s in bracket divided by 2a. 2 is going to cancel out, and we are left with t is equals to minus u plus or minus the square root of 2u square plus 2as in bracket divided by a. And simplifying further, t will be equals to 1 over a in bracket minus u plus or minus the square root of u square plus 2as in bracket, and our final answer is D. Here are some exercises for you to try your hands on at home. And for more insight of this topic, you can check out the chapter 3 of our JAMB Indifferent textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.